We talked briefly about the commutative property and how if we are really being sticky about the North American way to write 7 times 4, which is 7 groups of 4, and versus 4 times 7, which is 4 groups of 7. It is that we can draw rectangular arrays or area models for each one of these. So 7 times 4 would be this. So that's a 7 times 4, and 4 times 7 would be something like this. So, and here we can see the 4 and the 7. Now, children will very quickly tell you that if I just tilt my head, what used to be this 4 times 7 is going to start looking like 7 times 4. And it really takes them no time to make that generalization. And so this commutative property is actually quite intuitive for them. And it takes probably a 1 second conversation, maybe 1 minute conversation about why that's the case if you connect it to the geometry and to be able to actually tilt your head or rotate the piece of paper. It's the same thing with rectangles, because if you have 5 by 9, and we can actually draw all these lines and count that there are 5 groups of 9 squares of 1 centimeter squared size, then again we can tilt the paper or tilt our head, and we will get the fact that 5 times 9 is the same as 9 times 5. Now, and in general, again, A times B is B times A. All of those conversations about the commutative property are actually very easy because they rely on our kids' ability to understand rotation and tilting your head or rotating the piece of paper. So this is not a difficult concept at